So, hello guys, it's been a long time, but I'm finally back with a new video. This one's about science, particularly on neutron stars. I hope you enjoy. Hello everyone, I'm Rushan Basu, grade 6, and today I'm going to talk about neutron stars. When we talk about neutron stars, the first question that arises is, what are neutron stars? Neutron stars are formed when a massive star, several times bigger than our Sun, runs out of fuel and collapses. This is called a supernova explosion. If the star is about, say, 20 times bigger than our Sun, then the outer crust sheds off and the core collapses. The electrons and protons merge to form neutrons. This is called a neutron star. This collapse leaves behind the densest object known to mankind. An object with up to twice the mass of a sun squished down to the size of a city. One sugar cube of neutron star material would weigh about 1 trillion kilograms, or 1 billion tons on Earth, about as much as a mountain. To put things into perspective, imagine putting Mount Everest into a coffee cup. Did you know that 1 cubic centimeter of neutron star material can hold the mass of the whole human population? Isn't that amazing? You must have heard that black holes don't let light escape. Well, neutron stars are a bit different. They do let light escape, but light is bent around it, which means that we can see the front of the neutron star as well as parts of the back. Their surfaces reach a million degrees Celsius compared to a measly 6,000 degrees of our sun. Now, you must be wondering, what goes on inside a neutron star? Well, to answer that question, let us continue. The crust of a neutron star is very hard and is free with electrons. Neutron stars are thought to be made up of a soup of neutrons covered with a solid crust. The crust is composed of crystals of neutron-rich atoms. Now, the inner core is a very big mystery. The core of a neutron star is filled with ultra-dense matter and is rumored to be filled with quark-gluon plasma. So what is quark-gluon plasma? Well, due to that immense compression and gravity, the protons, electrons, and neutrons collapse, and the things which make them up, quarks, they spill out. So this is called the quark-gluon plasma. And there might even be strange quarks or strange matter inside. But remember that this is not proven, and till now they're just rumors. So, till now it remains as one of the biggest mysteries of our universe. Now I come to the types of neutron stars. There are two main types of neutron stars, pulsars and magnetars. Let us start with pulsars. Most neutron stars are observed as pulsars. Pulsars are rotating neutron stars observed to have pulses of radiation at very regular intervals, which range from milliseconds to seconds. Pulsars have very strong magnetic fields with funnel jets of particles out along the two magnetic poles north and south. These accelerated particles produce very powerful beams of light. Often, the magnetic field is not aligned with the spin axis, so those beams of particles and light are swept around as the star rotates. We see pulsars turn on and off as the beam sweeps over Earth. One way to think of a pulsar is like a lighthouse. At night, a lighthouse emits a beam of light that sweeps across the sky. Even though the light is constantly shining, you only see the beam when it is pointing directly in your direction. Same goes with pulsars. When the pulsar's beam of light hits you straight at your eye, that is the only time when you see the light. Otherwise, you don't. So from Earth, we see pulsars as a blinking light. It goes on and off. Let me give you a short demonstration of how pulsars rotate. Wasn't that intriguing? Now I come to magnetars. One of the other types of neutron stars is called a magnetar. In a typical neutron star, the magnetic field is trillions of times that of the Earth's magnetic field. However, in a magnetar, the magnetic field is another 1,000 times stronger. So you can imagine how strong a magnetar's magnetic field is. In all neutron stars, the crust of the star is locked together with the magnetic field so that any change in one affects the other. It's just like a chain reaction. The crust is under an immense amount of strain, and a small movement of the crust can be explosive. In a magnetar, with its huge magnetic field, movements in the crust cause the neutron star to release a vast amount of energy in the form of electromagnetic radiation. Now here's a very curious example. A magnetar called SGR 180620 had a burst where in 1/10 of a second, in a fraction of a second, it released more energy than our sun has emitted in the last 100,000 years. Can you believe that? Another star has released more energy than our sun has in a fraction of a second than our sun has in the 100,000 in the past 100,000 years. Isn't that wonderful? So now I come to how did space science help in discovering neutron stars? Well, in 1934, astronomers Walter Baade and Fritz Zwicky of the California Institute of Technology, also known as Caltech, first predicted the existence of neutron stars, but they were not discovered until over 30 years later. Some neutron stars emit beams of electromagnetic radiation that makes them detectable as pulsars. Indeed, the discovery of pulsars by Jocelyn Bell Burnell and Anthony Hewish in 1967, as we can see 30 years later, was the first observational suggestion that neutron stars exist. Thank you for attending my presentation. I hope you enjoyed it.
Thank you guys for watching the video. Please subscribe if you're new to this channel, and please like and share this video. So stay tuned for Down to the Quarks. I'll be back with a new video pretty soon. Thanks.